Alright, in this video we will continue to solve rational equations such as this one right here. I'm going to solve it algebraically, meaning by hand, but then I'm also going to solve it using my TI-84 graphing calculator. So, I cannot simply cross multiply because this is not just a fraction equal to a fraction. So here's what I'm going to do. I need to multiply by anything I see in a denominator. That way I will cancel out the denominators. Alright, so if I do that, that means I'm going to be multiplying by x. X is the only thing in the denominator. So multiplying by x will look like this. I'll wind up having an x here, here, and here. All three places in the problem. Now, on the left, going from left to right, when I multiplied by x here, that gives me x squared. These x's just cancel out. That gives me minus 4. And here I have 3x. Now, I can easily get everything on one side of the equation by subtracting 3x from both sides. Notice that it goes in the middle between these two, and it doesn't combine with anything, no like terms. So this is going to give me x squared minus 3x minus 4 is equal to 0. Now if this is factorable, we should go ahead and factor it. So x squared is equal to x times x. 4 could be 2 times 2, but it could also be 4 times 1. Inner plus outer equals middle. Inner I have 4x, outer I have 1x. I'm trying to get negative 3. So I need a negative 4 and a positive 1. So there's my negative 4, there's my positive 1. Also, negative 4 times positive 1 equals negative 4, so we've done it. That's how you factor. Alright, but to find the solutions, I need to take these factors and set them equal to 0. So that's going to give me x minus 4 equals 0 and x plus 1 equals 0. So I'll have two solutions unless one of them is extraneous. Alright, I'll have x equals 4 from here, and I'll have x equals negative 1 from here. So my two solutions. Now I need to look back and make sure that none of these are excluded values. So looking back, what are the excluded values for this problem? Hold on, my eraser is slow to work today. X is in the denominator. That tells me that x cannot equal 0. That's the only excluded value. X cannot equal 0. Neither one of these are 0. So I should be okay. Now let's look at the TI-84 and see how we could have solved this graphically. Alright? It will help us understand what all this really means. If I write this in the form of two functions, so I will use the left side of the equation as one function, alright, y equals x minus 4 over x. And I can use the right side of the equation as a separate function, y equals 3. That's just a horizontal line. So, x minus 4 over x. To the calculator. I hit y equals to get to where the equations are. I'm going to just hit clear to wipe out whatever's in there. Alright, so my first equation, x minus 4 over x. So x minus, to go into fraction mode on a graphing calculator, you hit alpha y equals. Option 1 is fraction mode, so I'll just hit enter. And so we have 4 over x, right? Yes. So that's my first equation. I'm going to go ahead and hit graph just so I can take a quick look, see what it looks like. Alright, interesting. Okay, so there seems to be a vertical asymptote at 0, and that's what's going on here. Now, the other equation is y equals 3. So I'm going to go back to y equals, I'm going to go to the second line, and I'll just put 3, because that gives me y equals 3. This will graph as a horizontal line in red. Alright, so the solutions should be the x values of these two intersection points. Alright, so here's one intersection point and here's another. The calculator will find it precisely if I use the one of the functions under the calculate menu. So I will hit second trace to access the calculate menu, and I want intersect. Now I could either scroll down to intersect and hit enter, or I could just type the number 5. So now it's doing the intersect function. Okay, I need to find my cursor. Okay, so here's the cursor. I'm going to try to get close to one of the intersection points. As close as I can. I went a bit too far. Alright, that's pretty close. So, once I get very close to the intersection point, I'm going to hit enter. So, now it says second curve, I just hit enter again. It says guess, I just hit enter again. So it tells me the intersection is 4, 3. The y value is not important. The x value is the solution. So one solution is 4. And that corresponds with what we found algebraically. One solution is 4. Okay, now the other solution is over here. So I'm going to scroll to the left, trying to get my way over there. Alright, I'm very close. I probably shouldn't have done that until after I did the calculate function. So second trace to get to the calculate menu, I'm going to type the number 5 for intersect. Okay, and now I'm back over here again. So I'm going to go off screen, but I'm just going to scroll all the way over here. You know what, maybe on the blue function, I'll just do it off camera. So here I am close to the point of intersection. I'm going to just hit enter 3 times. So the intersection is -1, 3. The point -1, 3. The solution is just the x value. X equals -1. And of course that is what we found algebraically. So that's how you can solve a system, not a system. That's how you can solve a rational equation algebraically and using our technology, using our graphing calculator, solve it graphically. Let's do one more in this video. Alright, let's try number 7. Now, this one I should be able to cross multiply as far as solving it algebraically, because this is a fraction equal to a fraction if I look at this as 3x minus 1 over 1. So I'm going to cross multiply, which means I can get one side of my new equation by multiplying these together. Of course, 1 times x squared plus 1 is just x squared plus 1. Now I will make the other side of my equation by multiplying these together. So that's going to be 3x minus 1 times x plus 2. Over here I'm going to wind up having to FOIL this or double distribute or whatever you want to call it. So 3x times x is 3x squared. Inner plus outer equals middle. Inner I have negative 1x. Outer I have 6x. That gives me 5x. And then negative 1 times 2 is negative 2. So I FOILed it. So here I still have x squared plus 1. I'm going to get everything on one side of the equation and get 0. I don't like to have negative numbers, so I'm going to subtract the x squared from both sides. So if I subtract x squared from both sides like this, and if I subtract 1 from both sides like this, notice how I put my like terms together, of course. I'm going to get 0 equals 2x squared plus 5x minus 3. Now perhaps this is factorable. Let's try. 2x squared can only be 2x times x. 3 can only be 1 times 3. But maybe it'll be 1 and 3, or maybe it'll be 3 and 1. I think it's going to be the other way around. Alright, inner plus outer equals middle. Inner I have 3x. Outer I have 2x. I'm trying to get a middle of 5x. If I leave both of these positive, that'll make positive 5. That would mean both of these would be positive. But wait a minute, that is not going to give me negative 3. Why did I think it was going to be this way? See how that's not giving me negative 3? So I chose badly. But that's probably good, so you can see, so you can find out how to tell when it does not work. So instead, I'll try it the other way, with 1 here and 3 here. Inner plus outer equals middle. So inner I have 1x, outer I have 6x. To get a positive 5, I need a negative 1 and a positive 6. So there's my negative 1, and this will give me positive 6. This time, negative 1 times positive 3 is negative 3. So that's how you factor this. To get these solutions, I need to set these equal to 0. So 2x minus 1 is equal to 0, and x plus 3 is equal to 0. This is going to give me 2x equals 1. So x is equal to 1/2. That's one solution. And this is going to give me x equals negative 3. So let's do a quick check and make sure none of these are excluded values. Looking back at the original problem, and specifically looking at the denominators, there's only just the one denominator, x plus 2. So there is an excluded value. We know that x cannot equal negative 2 because of this. Well, none of these are the excluded value, so we should be good. These should be the actual solutions. Now, let's check our TI-84 and see how to solve it graphically. If I want to solve this thing graphically, I need to make equations to graph by setting the left side equal to y. So that'll be one function, and I'll set the right side equal to y. So I have two functions. I want to see where they're equal. Graphically, that means I want to see where their curves intersect. So I will graph each of these separately on my TI-84 graphing calculator. So let's see if I can remember this. X squared plus 1 over x plus 2. Hit y equals, clear it out. On a graphing calculator, to go into fraction mode, you hit alpha and then y equals. Option 1 is fraction mode, so I'll just hit enter. And I already forgot what it was. X squared plus 1 over x plus 2. So here we go. X squared plus 1 over x plus 2. That's my first equation. Let's hit graph and take a look at it. Okay, so there's the first graph. Of course, there's an asymptote at -2 because that's where the excluded value is. Now, the other equation is y equals 3x minus 1. So I'll go to the second function and I'll put 3x minus 1. That should be a straight line, y equals mx plus b. So there is my straight line. Now I seem to have two intersection points. I see one about here, and then there's one just about here. So to find the point of intersection, I will hit second trace to get to the calculate menu. And in here, option number 5 is the intersection function. So I'll just type 5 to access it. My cursor is here. I'm going to just move over a little bit to try to get very close to the intersection point. Once I'm very close, I really will just hit enter 3 times. So the intersection is 0.5, comma 0.5. Only the x value matters in this context. That means one of my solutions is 0.5. Well, that's the same thing as 1/2, so that makes sense. Now, what about the other solution? It's down here somewhere. I can't see it very well because it's going off the screen. So what I need to do is change the window. If I change the minimum y value, I should be able to see lower. So instead of -10, I'm going to make this -20. Okay, now I can see clearly my second intersection point is right here. So again, if I do second trace and choose intersect, option 5, now I'm headed towards this intersection point. Now I want to get as close to this point as I can. Now, if I hit the left arrow key, then I'm going to start to slide to the left. Eventually, I'm going to it'll jump over to the other function and I'll get here. But I want you to know, if I hit one of the vertical arrow keys, watch what happens. I jump to the other function. So now I'm here. So now if I hit my left arrow, now I'm going to travel along the red function. So I like to be able to see where I'm going, so that's why I did that. So I'm pretty close. I'm going to hit enter 3 times. -3, comma, -10. So the solution should be x equals -3, and that is the other solution we found algebraically. So that is how you solve a rational equation algebraically and graphically.